Like this one, I'm sure in physics you've seen similar one, but we're gonna try to learn a new method, something that we can use it later for other stuff. We have two, let's say card, but we consider them particle, A and B, because the question didn't talk about the size of these things, right? And they have been connected, like they connected via these pulleys, nothing unusual, and everybody can see what's going on, right? And we mark point C on the rope for just with a maybe marker, just to know where things going. First thing first, we need to have a reference, all right? So why don't I like pick this line as my reference, like on this wall. So this guy to be the basically reference, and it's a fixed line. It doesn't move. And then the next things, I'll look at the B and I say, well, in order for like to simplify the problem, I know wherever B goes, this point goes with B, right? So I'm just removing everything after this dot on the right side. So to just simplify it for myself. So then simply I can say, well, if I set a line there, I can claim that this is, let's call it XB. You guys agree? So this is my reference, and wherever that dot goes, it's going to be position of B. So if I take the derivative of that, x dot B, of course, it's going to be the velocity of point B. And if it comes back, it's going to be negative. So we'll do similar things for the other guy here. For A, wherever this point goes, we know that it's going to move with that. So, and so the line over there, and simply I say, well, let me show it by red so we can distinguish it. This is XA. Okay, but their direction is different, right? So XA toward like down or toward left is positive, which is okay. This is what we decided to set at the beginning. Now, let's look at this rope. And can I say, let's say, can I say that this length, that I'm just highlighting on the rope, and this length, they are equal to XB. Can I say that? If you check, they are like parallel line, right? If I continue this line, you see I'm right. At this moment, I can write this. Let's continue this line as well. And what about this? This length, and this length, they are all equal to XA, right? And what about, in a moment, you will see what I'm doing. So we know this length. I'm just highlighted by pink, and we know this length as well, right? So this is, let's say, this length and this length, because simply we know that this length is 2 pi r. The same with the other pulley. And also this length as well, we know it's a fixed length. Like it's not gonna stretch, right? The rope is not gonna stretch. So with this like schematic that we have, can I write, and you tell me if I'm wrong, the length of the rope or a string or whatever it is equal to 2xb plus 3xa plus 2 pi r plus, let's call this fixed things, maybe L or whatever. And then can I write down 2xb plus 3xa is equal to some constant. Because see, r is constant, 2 pi is constant, all of the stuff around here is are constant. L is a fixed value, is constant, like this pink length, right? And then the length of the row is not going to stretch, is always constant. We took all of this stuff, we bring them back to the right side, right? We simplify it. And so we know that 2xb plus 3xa is equal to a value, which we don't know and we don't care. So take a look and see if something is not matched with your thought and you are not agree with, or if it's not clear. Because if we get to this point that we find a relation between xa and xb, then problem is solved. The rest is just a simple derivative, which you know from math, right? If I take the derivative, then I can write down simply 2x dot b 3x dot a is equal to 0. So this is a relation between VB and VA. And I'll do the same. Take another time derivative, 2 x dot b is going to be x double dot b plus 3 x double dot a equal to 0. And similarly, VB minus 1.5, sorry, AB, right? We are calculating acceleration. A. Okay, so done. The question asks to find the relation between these two, and we did. So if you're wondering why this negative sign, look at the reference that we picked. The reference that we picked, right? They are in opposite direction. So it just shows us that everything is correct. When B goes up, still A goes up. But the way that we show it is just this opposite direction, which is okay. If somebody look at your diagram, look at your values, they understand what this negative means, right? And you have the values, you can just plug them in. Question gave you VA, VB, and you're done. I'll give you a moment to write, and later you can just substitute these values, right? You have B information for velocity and acceleration.
Hello, Professor.
Yes, go ahead, Abby.
Hi. Actually, the way, like the place where you wrote 2 into 2 pi r, like for the uh, length of the circumference of the pulley circle, but isn't it a semicircle? So will it not be pi r for each?
Sorry, so you're saying like this 2 pi r.
So will it
Oh,
not
pi
be
r.
pi r?
Yes, yes, that's correct, because it's a half a circle. Thank you.
Yeah.
All right. So that's a good one. Thank you. So guys, maybe you notice it, but I didn't. This is half a circle, right? And this guy is pi r. Okay, so this is all good now. I'm gonna check chat to see. Okay, so please check when you take the derivative I saw in chat. Derivative of x is x dot, and derivative of x dot is x double dot, right? Don't confuse it with when, let's say you have x2. When you have x2, you take the derivative, it's going to be 2x x dot, right? Because once you take the derivative for this power, it's going to be 2x, and then derivative of this x, which is going to be 2x x dot. And you take another time derivative, it's going to be 2x dot squared plus 2x x double dot. Okay. And like similarly, when something is equal, let's say x is equal to sine theta, you take the derivative, it's going to x dot is going to be theta dot cosine theta. This is something that we had like here, right? You saw here, when we take the derivative, it was a little bit more complicated. I'm just going to check the chat again. Okay, good. All right, so let's then, if there is no question here, let's move on. Take a moment and try to see if you can solve this problem using the same concept that we just explained. Your task is finding the length of the rope. So we need to find the length of the rope. And I believe everybody understands the mechanism. It's very easy, right? This tractor is moving to the right. It has a velocity like this point. And this velocity is equal to x dot. So this information we know. What we are interested to find is we want to find out VB, which is VB is equal to y dot. This is our task. Our task is to find the relation between x, y, and h, because this is all the information that we have, nothing else. Don't look for any extra things here. Any idea how we can solve this problem? What is the length of the rope? I'm sure you guys know this section is going to be 2, because we have 2, right? H minus y. That's easy. What else we can say? I'm going to check chat to see. Yeah, square of x squared. Thanks, Felix. That's right. Because we know this length also. This length is, you can say, right, x squared, h squared. In this big triangle, right, we have x and we have h. So then the length of the rope, problem solved, is equal to x squared, h squared, plus 2h minus y. Let's simplify it. Then what I get, x squared, h squared, minus 2y is equal to a constant, which we don't care what it is. Okay, I just move these two h to the left, and h is always constant from ground to the ceiling. And problem solved. You just need to take the derivatives. You see, when you figure the geometry, then the rest is easy. Let's do that. Take the derivative of this guy. I'm sure you remember. So derivative of like inside this guy. So it's going to be 2x x dot divided by my pen behaving like that, and divided by 2x squared h squared, which you can get rid of that too. And here we have 2y dot equal to 0. All right. So from here, I can get rid of 2, and then I can simply write down y dot is equal to x dot x squared h squared. and the rest you just substitute them, right? This is the velocity of A, the tractor, and we found the rest. If the question asks for acceleration, then you need to take the derivative one more time, which please do it as a practice and assume that this guy is constant. So like tractor is moving with a constant speed. So it means x double dot is going to be 0 when you take the derivative. But as a practice, please do it. So to make sure. I'm going to chat. So it is, right? If you simplify, like here, you take the derivative inside. What is the derivative of x power 2? It is 2x x dot, and then divided by 2, like x squared h squared. And then you just simplify this one. Okay? Oh, maybe you guys are right. So always when I make a mistake like that, I return back to this. Let's say we have x squared, h squared, power of 1 over 2. Maybe I'm wrong. So let's take the derivative of this one. Everybody knows how to take the derivative. It's going to be half of x squared, h squared, and then this one is going to be minus 1 over 2. And then the basically derivative of inside, which is 2x x dot. Okay? So we can get rid of 2, or I'm missing something here, guys. Then is we are checking our math. I know these things are easy to forget. So I write it down this like a square root as this power 1 over 2 coming here. And then, yeah, I guess I can get rid of 2. Oh, you're talking about these 2. Guys, please just unmute yourself and tell me. So we have a 2 here. I thought you were talking about that 2 for the derivative. So it's going to be a 2 over here. Okay. So I was barking on the wrong tree then. Right? Okay, maybe I need more coffee. So let's check it with each other and make sure that everything is correct now. We missed 1, 2 here, right? This is this guy here. So you see, it's very easy to like miss things here. So we have to be careful. Because sometimes when we find a solution, like which is the hardest part, then the math, we may do silly mistake like that. Okay, so that's good. If there is no question, then we'll continue. Let's take a look at question 5. And last lecture, I showed you a mechanism that how these things is working, right? You saw it, this mechanism. Maybe I'll show it one more time. I just need to find it. Oh, here it is. Okay, so let me share my screen. So last time I showed you power screw or lead screw. Just as a practice, guys, for yourself, try to find the difference between lead screw and power screw. So lead versus power. You guys are in manufacturing or mechanic, or maybe iGens. So this lead or power screw is going to be a good friend with you. You're going to use it in different things that you will build in future or you will analyze in future. So lead screw is rotate. It moves something left and right. It's more like a nut and a bolt, right? But this time the bolt is fixed and just rotating, the nut is moving. And it can be used in different mechanism, like this, in this silly mechanism, which the yellow part is moving as the lead screw is rotating. And as a result, you see there is like a pin and a slot here, which they move together. I guess in maybe today your tutorial will show you like something similar, how to build similar mechanism, but of course in 2D. Later in the course, I'll talk about also how in 3D you can build this mechanism, which is more fun, right? But first thing, like a step by step, okay? So let's, then now that you know how things are working here, like the first task in dynamics, figuring out how things are moving, right? Then let's solve this problem. We want to find out the relation between like theta and x, which is super easy, right? You can look at this shape and find a right triangle. Right triangle is a nice thing to have in dynamics or in any other course, right? Imagine how difficult our life would be if there is not a good relation in a right triangle, right? It makes the life easier. So can I write here tangent theta is equal to x over h? I guess I can, right? Because I have a right triangle. And keep in mind, we are going to relate theta with x. And maybe this is the best way to relate them. Sine, not useful because then I have another parameters which I'm not going to use. So we did the hard job finding the geometrical relation. The rest is just being careful about math, not making mistake that I did, and taking derivatives, which I'm sure you know how to do that. So the left side, x becomes x dot, right side, tangent theta. So first we go to take the derivative of inside, which is theta, becomes theta dot. And then we are worried about the derivative of tangent theta, which is 1 over cosine squared theta. Problem solved. We have x dot, right? This is equal to v. Which question gave the information to us? 25 unit, be careful about the unit, millimeter per second. We have h. And what else? We need cosine theta, which also is easy to figure out. I'm just going to write it down here. So cosine, or we just need theta, right? I can write down tangent theta, x over h, but in this moment, x is 120 because question asks for just find it at this moment. And then over h, which is 160. From here, we will find theta. So I need my calculator. Guys, if you don't have a calculator, get one of these. I bought it from Staple. If you guys can see my screen. Maybe you have, maybe you are rich and you can buy more expensive one. This one I like, it's just $10, $15, and it has scientific notation. And the good things about it is that all the exams, it is acceptable. Of course, now that we are online, nobody see you. You can use the most advanced calculator. You can use your computer. But next semester, when we return back, for other courses, you cannot have any calculator for exams, right? This term, and also me, I don't care. You can have any type of calculator. So let me check chat. Yeah, Casio is great. So if I use my calculator, let's find basically 120 divided by 160. So it gives me a nice value of 36.87 degree. We keep two decimal point, two figures after decimal points. So then I have theta also, 36.87. I have everything that I want. Then I will find theta dot. Okay, 0.1 radian per second. Oh, nice number, right? Couldn't know out of this ugly number, we get this nice number. So that's omega for this link. All right, I'll just let you guys to write down, and then if you have any question, please ask before we move to the next topic. So question is asking, aren't we supposed to use theta as radian? It doesn't matter when you calculate cosine theta, right? It doesn't matter if you use radian or basically degree. Cosine gives you the same value. But on your calculator, you have to be careful if you set it on degree or on radian. All right? Okay, so if there is no question here, then let's move on to the next topic. Okay? I'm just gonna go to lecture 6, which is a nice, short, and easy topic. And close that. So we're going to talk about relative motion. What is relative motion? Another topic that I'm sure you remember from physics. Let me move myself up there. You know, guys, when I do the Zoom lecture, there are many things at the same time that I have to figure out. It's not just the lecture by itself. Made it more fun, a little bit more miserable. So let's say let's say we have a particle somewhere here, and then let's say we have the information for this particle. By information, I mean the dynamics information. For example, we have a coordinate, and let's call it x and y, x and y. And we know this particle is moving, let's say, on a path, curve, or whatever. And let's say I have the coordinate and I have the information for this particle. So I have RA. And when we say we have RA, it means we have x dot A and y dot A, right? You saw that one. We say RA is a vector and is equal to XAI plus YAJ. But let's say I'm interested to know more about this point A. when somebody is over here, is watching that guy. Okay, so this person likes to know more about A. And okay, let me. So we like to know, like this guy. All right, this is what we want. Oh, let me correct myself here. This is not RA. Let's move back, guys. Okay, this is RA. Information for point A. So let's move back one more time. So this is not RA then. I'll tell you what it is. So this is point A. We have X and Y, and we have all the information. Let's call it R. We have R dot and we have R double dot. But we are interested to know more from this point. Let's call it point O or whatever. All right, this is what we are looking after. So I set my axis over here as well. And maybe we, like in this question, maybe we have the information for the axis, but not for point A. Like let's call this point B. And we have RB. So we have RB. This is then the question. We have RB, but we are interested in finding RA. And also, we have some information for point A when we look it from the perspective of this point B. So it has a name here, which we call it RA with respect to B. And let's assume we have this information as well. Okay, so let's look at this diagram to make sure that you understand it. And if you have a question, please ask now. So this is what we have. We have all the information for point A when we look at point A from point B. We call it RA with respect to B. Assume that we have all the information for point B. Like this person from point O, he can see where this point B is going. So he knows RB, but he's interested in finding out this RA. Okay, and to be like more accurate, later in the course, we don't need to, later in the course you will see, we'd better show this one RA with respect to O, and this guy RB with respect to O. But since everybody knows that we are talking about this person who's sitting at point O, we are just lazy and simply write RA, okay? Because O is our base, and then we don't care to write it down. This is the relation that, again, from math, from vectors, we can write that RA, our unknown, is equal to RB, the reference that is moving, plus RA with respect to B. And this is all vectors. So if we have this relation, then we take the derivative and we are good to go. Okay, this is what we call the relative motion. So the same relation, if I take the derivative, I can write down then VA is equal to VB plus VA with respect to B, and for A as well. AB, A with respect to B. Okay? So I'm going to make this box bigger. because for now, this is like as you see it here. Later in the course, you will see there are many other things will be added here, which we don't need them now, but later you will see there are other parameters and make it more fun. Okay, but for now, it's just blue things, the relation that we have. And this green one is something that's new. This bluish one, I'm sure you've seen it in physics. And if you haven't, it's a very simple topic. You know, it's relative motion. In physics, they showed you two cars are moving on a straight line, the speed of one car with respect to another. But we made it a little bit more. Maybe we are moving on 2D. We have both X and we have both like X and Y direction. Let's solve one simple example together and see how we can solve it. I'll let you guys to read and I'll do the same. So, well, we have a car is moving. That's the first things, VA. And this VA, we need to do something about its unit. We don't like kilometer per hour, so we say every kilometer is 1,000 meter and every hour is 3,600. Meter per second. Then what else we do? We know, well, we know this Ferris wheel is rotating with omega 3 revolution per minute. So omega is 3 revolution per minute. Remember, we said in this course, always radian per second. We know every revolution is 2 pi radian, right? 2 pi, and every minute is 60 seconds. So it's going to be then pi over 10 radian per second. So we sort this part out, and I'm sure you guys now quickly can find the velocity of B then. Like this vector, right? It's a circular motion, and you saw it from last lecture. A circular motion, the velocity simply is r multiplied by omega. So Vb is equal to r omega. Do we know r? 9 meter. And do we know omega? Yes, we just found it. And what's the unit? Meter per second. So we problem sort of solved. Like we have VA, we have VB, and we want a relation between them. Let's see what the question asks. It's ask, find the relation between velocity and acceleration of the car relative to observer B. So this is what we are looking after. So we want to find A with respect to B. This is what we are searching for, okay? And also the question asked about acceleration. So we need to be careful about that. Let's write those things. And we want to also A with respect to B. So we know A has an acceleration, 3 meter per S2, that's good. What about AB? Do I have an acceleration for B? This guy is constant. So it means I don't have any alpha, right? But whenever we are on a circular motion, we should have an acceleration an. So let me write it down here. An. So I just made it a big vector so you guys can see. And an, we know it is equal to r omega squared. We have r, and we have squared. Let me simplify this one and see. I use my calculator. Multiply by 9 divided by 100. So it gives me 0.89 meter per square second. So this is our setup. We have now everything that we need, right? We have the acceleration, we have the velocity, so this car also has an acceleration. All you need to do is just write down the relation here. So can I write VA is equal to VB plus VA with respect to B? Yes, we can, right? The relative motion, you just saw it. Always I remind myself, like this time, like this relation, we can easily make mistake in exams. When you have A and B, remember the order, like VA over B is always VA minus VB. This is how I remind myself. Let me write it down here for you. Maybe later you can use it. So VA over B is always VA minus VB. Like sometimes we may forget the order, right? This is how we can remind ourselves. So, and the same we can write down for acceleration. AA is equal to AB plus AA with respect to B. So if you guys agree with this point, then the rest is just substituting these values. But we need to do something about this VA and VB. We need to change them to I and G direction, right? To X and Y. So this is I over here, and this is J. This is I, and this is J. And I'm sure you know from maybe 260 that you can find the components of these vectors. And maybe also in physics, right? So if I put X and Y here, just for simplicity, so I know what I'm doing. So what are the components of this guy? So you tell me, I have one component in X, one component in Y, right? So it's going to be 0.9 pi and cosine 45, the angle is 45. And this guy is going to be 0.9 pi sine 45. Similarly for the other guy, so you have this guy here, you have that one there, right? And all you need to do is just find the components, this one and this one, right? So let's just substitute these values here. So VA, it is 3I because it is on horizontal line. What about VB? We just find it, right? It is 0.9 pi cosine 45 I minus 0.9 pi sine 45 J. And what is VA over B? This is what we are looking after. We want to find it out. And we'll do the same for this guy. What is the acceleration? Oh, I made a mistake, guys, here. Our velocity was 18 over 3.6. Our acceleration is 3I. So AB, we just find it like 89 cosine 45 negative I minus 89 sine 45 J. You see, I'm talking about these two guys, right? This one is 89 cosine 45, or the way that I wrote it, sine 45. And this guy is 89 cosine 45. And they are negative, right? Plus AA with respect to B. And the rest, you just do the math, which I will complete it after the lecture on the notes, right? So again, you guys know to do the math, you just add the I things together, the J things together. Like for example, here, everything's go to the left. So J is alone, so we just leave J there. But I, we have this value and this value, we add them together. Let me quickly check chat. So question is, what about AT? So what about AT? Kamran, you tell me. What is the formula for AT? It's a good question. Kamran is asking. He's asking, what about AT? AT, I'm writing down here, right? It's R alpha, but alpha is constant. Do you agree, Kamran? We have a circular motion, but omega is constant. Imagine if the Ferris at the beginning, maybe omega is not constant, but when it's settled, and then it's going to be constant. And this question didn't tell us that we have an alpha. All right, so that's good. No question then here. So guys, if there is no question, then I want you to think about this problem. I'm just gonna take a couple of more minutes from you guys, and then you go to your next things for this course. So we have this flat car. Try to read this one, and I let you guys to think about the solution and then compare it with my solution. It's very similar to the previous problem. So we have this flat car, it's fixed at point O, and this pendulum is moving. And the question is just, for now, it's just talking about velocity. Later, we'll discuss the acceleration for this problem, which needs a little bit of work, but it's coming 3 or 4 more like lectures later. So the car is moving, it says, with the velocity of 4 meters per second. So that's one thing that we know. And we know omega is coming down. We want to know the absolute velocity of these like mass m. Okay, so from what you've learned so far, try to find velocity of this one. V, which you know, right? And also you have the velocity of this guy. But you know, whatever the velocity of this guy is, this point is going to have the same velocity because they are all attached together. So then I have this point, meter per second. Okay. And continue with the rest. I'll just let you guys to think for a moment. So then first things, this cart, we know its velocity is 4 meters per second. Okay. So it means we know the velocity of point O. Like this person is standing outside. He knows VO. He likes to know, let's call this point A. He likes to know velocity of point A. Okay? This is the question that we want to answer. What else we know? We also know velocity of A with respect to point O. This is not this person. person who is he's sitting at the top here, he like this person over here, or sitting, let's say, at the top here. Maybe this is the person. He knows VA with respect to O, right? It is R omega. And then complete the rest. I'm sure you should be okay solving it, but first solve it, then compare it with my solution. And we have the angle, yeah, the angle is 30 degrees. All right, good luck, guys. You guys should go. 5 minutes break before you join your basically your tutorial, which today you're gonna learn how to simulate some simple mechanism.